So, welcome to this first DISARM webinar organized by the International Dairy Federation. This event is part of the DISARM project. It's a European project. The webinar will be entitled, How can the management of clinical and subclinical mastitis be supported by sensor systems? DISARM is an active network dedicated to finding innovative solutions for antibiotic resistance and aims to reduce antibiotic resistance by reducing the need for antibiotics in livestock farming by focusing on disease prevention and prudent use of antibiotics. So if you want to know more, you will be able to check the website and you will find a lot of resources that are shared by the members. Today, we have the pleasure of having some excellent and renowned professionals working in the field of dairy cattle health. And each of them will provide a short presentation of the project that we are finalizing at IDF. So during the presentation, you might ask questions using the chat box of Zoom. And I presume that right now you know how this works. So please remain muted and with your video off. I'm going to briefly introduce the professionals that we have today. We have Dr. Ilka Klaas from DeLaval International, Dr. Gunnar Dalen from TINE Dairies, Professor David Kelton from University of Guelph, Canada, together with Dr. Alfonso Zecconi from Universita degli Studi di Milano in Italy, Dr. Honig from the Veterinary Service of the Ministry of Agriculture of Israel, and Professor Henk Hogeveen from Wageningen University. So with that, I am going to put the presentation in presentation mode. You will be able to access the presentation afterwards, and you have actually here the information about the project and who are the partners. So with that, I'm going to let Professor Henk Hogeveen to continue with the presentation.
Yes, thank you, Maria. Thank you for the opportunity to present some of our work. In fact, this work resembles the program
גם שמוליק כזה.
Okay. All buttons were muted, so I was muted apparently. Sorry for that. I'll start all over again. Thank you for the opportunity to present some of our work. It's kind of the result of quite a number of discussion within the action team sensors of the IDF Standing Committee Animal Health and Welfare, and it's showing well the progress we made. Next slide, please. How is this is a presentation, a webinar within DISARM, and how to link sensor management of mastitis to the prudent use of antibiotics. Well, it's quite clear. These are a bit of older Dutch data. In the years that in the Netherlands we were reducing the use of antibiotics, and you can see first of all that it worked. We did reduce the use of antibiotics in dairy cattle, but that's not the reason for this picture. The reason for this picture is that you can see that most of the antibiotics used on Dutch dairy farms in those years and still are used for mastitis management. For instance, dry cow therapy, that's the highest number of daily doses, but also intramammary mastitis, and probably also quite large proportion of the parenterally administered antibiotics are given to treat mastitis cases. So mastitis is a very important source of use of antibiotics, and therefore it's quite important. Yes, next. If you just look at some other data, you can also see that there's not much difference in the use of antibiotics on farms with and without AMS. These are a very recent study we published on the farms in one large veterinary practice, the University Veterinary Practice of Utrecht University, and all AMS farms, 42, and all farms milking with a conventional milking system, more than 5 times as many, were followed in terms of their use of antibiotics, and there were no statistical differences in the use of antibiotics, but there was a little difference in the application. So on AMS farms there was a bit more use of antibiotics the use of intramuscular parenteral treatments than the two other ones. While still in farms with an AMS, there's a little higher level of mastitis, which means that although there's a huge potential in the use of sensors in managing mastitis, farms that have those sensors are not performing better in terms of mastitis and are performing equal in the use of antibiotics. So by using precision dairy farming, we all believe that that can improve the management of animal diseases, because you can use all these measures on physiological parameters to support health management. And for instance, in mastitis, we can use that to automatically detect all kinds of events. And well, there's this field of precision dairy farming that is getting a lot of interest in the last 5 to 10 years that tries to work on that. And with that field, we want to continue working. So there's, next slide, please. So there's a big potential in the use of sensor systems, yet it seems that in mastitis management, that potential is not reached because it's all the same. So let us now have a short look at what a sensor system is. Often we think about sensor system as being the sensor, a sensor for electrical conductivity or a sensor for somatic cell count or whatever, but in fact it's a sensor system which is much more than that. So a sensor system consists per definition at least of one sensor, and potentially combined with other sensors or other data sources, for instance milk production recording data. And the hardware, the sensor is part of that system. Well, they deliver some data, but of course it's very important that these data are transformed into information by an algorithm. And many of the publications that we can see nowadays are aimed at developing these types of algorithms. And these types of algorithms, they do develop information. And that information is what farmers need to make decisions, either by a standard operating procedure, SOP, or a decision support model that can work on that. And a farmer takes those outcomes and can make a decision, or even systems theoretically can make autonomous decisions as well. So that's kind of a sensor system. It's a complex combination of activities of which the sensor, one or more sensor, is the heart, combined with an algorithm. Next slide, please. Good. What's the current status of sensor systems for mastitis? Well, there's two reviews available, one published in 2010, another one in 2013. And last year, there's quite some novel reviews or overviews being written about all kinds of aspects of sensor systems and precision dairy farming. But when you look at those reviews, then you can see that there is quite a large number of sensors used. Electrical conductivity, well, it's the most used sensor. It's been around for many years as of the start of automation in dairying. But color measurements are used, infrared measurements are used, and typically also to link to somatic cell count. There are some papers on the use of what they call biosensors, especially on the measurement of LDH. And there's a paper out on the measurement of somatic cell count. So there's a lot of work done there. But in order to look at that, we have to evaluate these sensor systems, and we do so by typically using two aspects: the sensitivity, which is the proportion of cases, so in this case clinical mastitis cases that are correctly classified, and there's a specificity, that is the proportion of non-cases correctly classified, so cows without clinical mastitis that are classified as being non-clinical mastitis. And there's a negative trade-off between both. So we can make alert algorithms that are very good at, that have a very high sensitivity, but that goes at the cost of specificity. and the other way around. And I guess if we have all our countries, if we look at the COVID-19 discussions and testing and whatever, all these aspects of test characteristics make place. Well, some time ago, some requirements were heavily debated, I have to say, and were written down that systems to detect clinical mastitis should at least have an 80% sensitivity and at least a specificity of 90%. But given that, we also have to look at things like that's called the true positive alerts that are correct. So that's great. The cow is on the attention list. I go to the cow, check the milk, and yes, this cow has clinical mastitis, but also false negative alerts, cases that are not detected. Next slide, please. While in practice, we do see that the sensitivity from systems is, well, for studies that we have seen, sometimes not more than 21%, with a very high specificity of 99%, or with a bit of higher sensitivity up to 50%, with a specificity of 90%. Here you see already the trade-off. So we make thresholds in such a way that the sensitivity goes up. That means that it goes at a cost of specificity. In theory, a paper that came quite high in terms of performance, with a specificity of 98%, we could get a sensitivity of 57%. And well, this can be improved by adding somatic cell count sensor to that. But then the other side of the medal is when you go and look at the false positive alerts. And this is a study I use a lot. It's not a very major study. It's also not published in a scientific journal. It's published at a conference. But in 7 Dutch dairy farms, we followed all the alerts of farmers. And in that study, so we went to the farms a couple of times, these 7 farms, twice per week, going for a number of weeks, and we looked at the alert lists and said, okay, hey, this cow is in alert. Are you going to check that, dear farmer? And then the farmer says, no, I'm not. Or yes, I am. And a bit to our surprise, well, not surprise, but quite quite clear, it's only 3.5% of all the alerts are checked by the farmer. The farmers are quite good at selecting cows because they had a high success rate. 2/3 of the cows they checked in that period, and we only had 15 of these checked cases, so 10 of them were indeed having clinical mastitis. So the farmers were quite well able to leave out cases that were not clinically ill for that. However, 74% of the mastitis cases were missed. So when we went into the barn and checked all the cows on the alert list, we found many more clinical mastitis cases than these farmers found. And that means that we missed a lot of clinical mastitis cases. Big question here is that bad? And I'll come back to that later on. What's the reason here? Why, with all this efforts of researchers, why aren't we able to make good algorithm, good sensor systems to detect clinical mastitis? Well, because mastitis is not black or white. So we have definitely healthy cows, no clinical signs, no increased somatic cell count, no intramammary infection, not at all. And we have severely clinical mastitis, everything wrong, cow is very, very ill. Well, the healthy cows and the severely clinical mastitis cows are the easy ones. But in between, there's a lot of a gradual decreasing of the situation or increasing of mastitis. You can do that by looking at inflammatory signs, for instance, the increased somatic cell count, and also at clinical signs. But it could be that the cow has mild clinical mastitis, so mild signs, flux or flakes, but no increased somatic cell count, or the other way around, has a very high somatic cell count without flux and flakes. And if you have one of these cows with an immensely high somatic cell count, no flakes, no clinical signs, well, then it's per definition not a case of clinical mastitis, and it's a false positive alert. How bad is that? So we should improve this because farmers are missing cases of clinical mastitis. And at the same time, they're not happy when they have too many alerts. Well, how to improve that? The first option is to start working with better sensors. That has been tried a lot. Use better algorithms has been tried a lot. Add other information has been tried. But we're working on this from the 1990s, and so far we're not totally successful. So the big question, what to do now? And that's where we as steering committee have been working on. Let's start formulate novel Mastitis situations to detect. Go for a farmer-centered, management-based definition. And then we start from the management. We thought, well, what do we need for the management? First of all, we need to immediately react when a cow has a severe clinical mastitis. No doubt about it, no delay, immediately a reaction. Severe clinical mastitis is one of the mastitis situations we have to look at. Then it's a second, and it's a big group. Those are the mild clinical or subclinical mastitis cases. No immediate action necessary. Maybe we should give the cow a little time to cure spontaneously. Let's not intervene immediately. The third option, where we can use sensor system, and that's not been explored a lot, that's in drying off decisions, where we want to distinguish between cows with an infection and cows without an infection. And finally, we want to have a look at herd health, herd level management, because we totally forgot about that, but also we want to make decisions at the herd level when the mastitis situation goes out of hand. Well, those are the four situations that the next speakers will talk about in more depth. For that, I want to thank you for your attention. Of course, questions can be asked after this, the four other speakers. Thank you.
Yes, hello everybody, and thank you. I will continue with the mastitis situation, cows needing immediate attention. My name is Ilka Klaas. I'm Dairy Development Director at DeLaval International. Next slide, please. So the first question is, what is exactly a cow with severe clinical mastitis? What do we mean by that? For us, it's a cow that has abnormal milk, with or without signs of swelling in the affected udder. And it's also a cow that has at least 2 or more signs of systemic illness. That could either be a high body temperature or too low body temperature. It would be a depressed cow that is off feed with low rumen activity. Also a severely suppressed cow that even may be dehydrated or show signs of shock symptoms. And if we look at different studies, we can see that the occurrence of the severe cases can vary a lot within and between farms, from very low occurrence, 5%, up to 22% in the different studies. And in a non-sensor world, we would typically carry out a clinical examination, look at the general condition of the cow, look at signs in the udder or in the milk. And also during the activities within the farm, we would, the farm staff could detect the cows when they fetch them for the milking process, or observe them during the milking or any other activities. So when we have the discussion, what should a sensor be able to detect? It's also important that we think about how good are farmers, how good is the staff to detect these signs of mastitis. And what do we think? How many cases are not detected or not detected in time? And do we have a detection problem here, or is it a problem that they're not reacting or acting as soon as possible? We also have different types of sensors. If we go to sensor-based detection systems, we could either have inflammatory indicators. Here I brought 2 examples from LDH measurements and from somatic cell count measurement. Ideally, we have a fast and steep increase of the inflammation, couple of days or milkings, and then we can see in those examples a dramatic drop again. Looks to me like clinical case treated successfully. But we cannot see from these data how severe the case has been. So if you go to the next slide, we know from studies challenging cows, for example, with E. coli, that there are a lot of other cow behaviors or signs that we can measure. And here we have examples from the body temperature peaking 18 hours after the challenge. But we can see that the feed intake, the maximum drop, first occurs after 36 hours. So when we look at the different cow behaviors, we also need to consider when in the timeline do they occur and how create then a reasonable sensor alert to detect this severely sick cow. And the next slide, please. So the challenges for the sensor system is we need to have a very short time window. And it could be that the milk appears normal while we have some general conditions that are already compromised. We could also have the occurrence that cows are not attending a milking machine or creating some failures, incomplete milking, etc. So it could also be a valuable information that there is an absence of sensor data within a certain window of time. In the ideal world, we do not want any cow going undetected. We want to have both a very high sensitivity and specificity. But if we check reality then, where are we in the process? Which studies have been carried out? What do we know? If we look at a recent study from Gunnar Dalen, who is also here today, based on one sensor, yeah, we can get pretty far. We had a specificity here of 99% at sensitivity 60%. And as we learned about these trade-offs, we can have specificity 90 with sensitivity 80. So it looks quite good, but it's not good enough for detecting all cows in the need of immediate attention. Another strategy could then be to combine different indicators, and that has also been published. And it looks like that we can actually improve the performance of a sensor system by combining several information, for example, available from robotic milking systems. And if we then also are able to include cow history, what happened before with that cow, then we can even improve the performance. However, it's still not good enough to stand alone. So going back to the graph that Henk presented previously, it looks like that we need to combine several sensor systems to create an alert and to initiate a specific SOP in the farm to get the cows treated. We can also see from scientific studies that including other data is beneficial. However, if we don't have a high enough sensitivity and specificity, it will still be important to have additional information and checks of the cows to make sure that we don't overlook the case. So what we in the group have been suggesting or are suggesting is that a sensor system that wants to identify those severely diseased mastitis cows needs to have a sensitivity of at least 95% and a specificity of 99%. And we also believe it's very important if this system detects any cow with a severely compromised general condition, we don't care if this is not really a mastitis, because any cow showing these signs should then be treated and handled immediately. The system should also be detect those animals within a short time window of 12 hours. So combination most likely of inflammatory markers together with cow behavior will be necessary, and also including information from sensor systems and non-sensor information to be able to detect these cows. And thank you, and by this I give further to Gunnar Dalen.
Thank you. So I will briefly talk about how we've proposed that farmers can use the sensor systems to manage subclinical and mild mastitis. Just so we're on the same page, we are using the IDF definitions. So a subclinical mastitis is a disease process not detected by physical examination of the animal, but it is an inflammation of the mammary gland, and it's not visible, but requires a diagnostic test for detection. And worldwide, the most common diagnostic test used is somatic cell count in milk. Mild mastitis is another inflammation characterized by observable abnormalities in milk, generally clots or flakes, but, and this is most importantly compared to the clinical mastitis cases that Ilka talked about, for mild mastitis, there is little or no signs of swelling of the mammary gland or systemic illness. Then why do we care about subclinical and mild mastitis? Well, I would like to show a brief cartoon illustrating some of the points. So what we see here is an automatic milking system with a fresh start. There are no cows with intramammary infection. And we have to introduce the players. If you go next. So the cows without scarves, they do not have intramammary infection, EMI. The cows with a more low grade, one could say environmental infection, have green scarf. And the cows with a more contagious or aggressive EMI have red scarf. So what happens, even though no cows were infected, for some reason individual cows will get a low-grade infection. It could be either due to reduced resistance in the individual animal or poor management. But these environmental EMIs are usually demonstrate a low degree of direct transmission from cow to cow, and this is here illustrated by the cow entering and leaving the AMS without leaving a scarf. However, if there's poor maintenance of the environment and or poor management of the animals, you can get more environmental EMIs. Here illustrated by the cow leaving a scarf in a bedding area for a new cow. But then a cow with a more contagious EMI is introduced with a red scarf. And what happens here is illustrated with the leaving a lot of scarves in the AMS, more cows get an infection. On a side note, in our work, we actually did not find the AMS system, did not have a strong part in the transmission of infection in our studies, just for reference, but this is for illustrative purposes. And since these, as I said, for the definitions, the subclinical and mild cases are not apparent to the farmer, so the spread continues to more and more cows without the farmer's knowledge. Suddenly, some animals get clinical mastitis, and it's here visualized by toppling over, and these need veterinary treatment, and the farmer and the veterinarian administers this, but the key point is that this is not necessarily the cow that introduced the contagion, and it's certainly not all the cows that are infected. So therefore, the transmission dynamics, they continue below the surface, so to speak. And the farmer and the veterinarian, they focus on the clinical cases and with more and more sophisticated treatment methods, but since this is the tip of the iceberg, it has no real effect on the mastitis situation. And if you go to next, the result is that you have many diseased animals, you have many infected, poor health and welfare, poor milk quality, culling, and a lot of frustration for the farmer. So the question is, can we use sensors to classify cows into these groups? The cows without EMI, the cows with environmental EMI, or with contagious EMI, or any other groups. But the point is, we have to identify these cows. So currently, for those not using AMS, pre-stripping is a widely used approach, and for checking the foremilk. But this is applicable for mild mastitis only, where you can see fox, but it's not for subclinical mastitis. You have the dairy herd improvement somatic cell counts that can be used. They are frequently associated with intramammary infection. This has been shown in many studies. I'm just mentioning two here by Shukin as a proxy for infection, and talking about the sensitivity and specificity. Actually the monthly or bi-monthly DHI samples are not hopeless and have a sensitivity and specificity of 65. However, there's a long time between testing. So in comes the various sensor systems, and with the aim to replace and improve on these approaches, the frequent testing is an advantage. The huge amounts of data, if we can understand them, would be an advantage. But unfortunately, as has already been mentioned, there are only minor improvements, nothing revolutionary. So from our own study, we found that we could increase the sensitivity and specificity to 70-80. So there is still suboptimal diagnostic test properties, and we have to face the practical consequences. And we believe that one key aspect to utilize these systems as they are is to be more aware of detection moment. If your detection moment is every milking, you should have a very high specificity for detection of subclinical and mild mastitis. Just very simple example, if you have around 100 lactations a year, you have 60,000 milkings, a specificity of 99, you get 2 false alerts per day, so that could be manageable. But if you lower your specificity to 80, then in this example, you would get 35 false alerts per day. And that's not a very useful sensor system. Whereas if you have the same sensor, but your detection moment is 1 evaluation before drying off, you could maximize sensitivity. And with the same number of cows, even if you lower your specificity to 80, you only get 20 false positives per year. And so the same setting for the system is then suddenly useful. So we argue that we need to adjust the use of the sensor systems for different detection moments, and we need more work to find a way to handle the challenge with suboptimal diagnostic test properties for these settings where we have multiple detection moments, and that's typically during lactation. Since immediate detection is not necessary for animal welfare reasons, and also detection of all cases is not necessary, we only have to keep the transmission level below the threshold for an outbreak. We argue that false alerts should be minimized. So for detection of subclinical or mild mastitis, the sensitivity can be lowered to 80%, but the specificity should be very high, 99.5%, especially during lactation. When we talk about the time window, we propose a rolling time window of around 7 days, and as this can also be incorporated into a weekly management routine. Well, these demands are too high. Yes, as I said earlier, with the current sensor systems, they are. So these are the levels we think they should be at, but the practical implication of our current diagnostic test properties is that the sensor systems cannot be left alone, and human supervision is important. And we argue that these systems can still be useful, but farmers, veterinarians, and other advisors need clear instructions for optimal use. Alas, the optimal method of intervention upon detection of subclinical or mild mastitis will always be subject to farm-specific circumstances and local regulation. So it's hard to impose a standard for everybody, but we, and also under this umbrella, the DISARM umbrella, we would like to argue that self-cure should be evaluated against chronicity. So it might not be necessary to treat all subclinical or mild cases of mastitis. Secondary testing is definitely a tool to reduce antimicrobial use. That is, if you have a sensor alert, you can do, for example, take a milk sample and do bacteriology or PCR or any other diagnostic test. And this should always be a responsible use of antimicrobials. The question of immediate actions versus actions at drying off will always be pending on the herd status, and we'll be hearing more about drying off shortly. Thank you.
Good morning, or I guess it's good afternoon if you're in Europe. It's good morning if you're in North America. My name is Dave Kelton. I'm a faculty member at the University of Guelph in Ontario, Canada, and a member of this action team on sensors. It's a pleasure for me to be with you this morning. My section that I'll present this morning for a few minutes is the application of sensors in the drying off process and managing cows at dry off. I think it's pretty clear to everyone that there is an increasing interest in moving from blanket dry cow therapy to selective dry cow therapy. We're further down the road in some jurisdictions than others, but it brings us back to the focus on AMR and reducing AMU, which is a big part of the DISARM focus. But also we're seeing changes in pathogen profiles on many of our farms and are rethinking the need for blanket dry cow therapy from that perspective as well. There are a number of questions around and issues around dry off, but there are probably at least two important questions in this process where sensors may play a role. The first is, how much milk is a cow producing at the time of dry off? And it's really to address the issue of, do we need to do something to decrease milk production prior to dry off? And then the second question is the one that's perhaps a little bit more central to our discussion today, and where I'll spend most of my time. In a herd that's using selective dry cow therapy specifically, is a particular cow a candidate for not treating with antibiotics? Is she at low risk for having an intramammary infection? And ideally, and perhaps somewhere down the road, we'll be able to even distinguish, is she more likely to have an infection with a major or minor pathogen that may also drive the decision that we make at dry off time with respect to treatment. The first question, how much milk a cow is producing, we certainly have in many of our systems now, not just our AMS systems, but most of our parlors, the ability to use daily milk weights for this purpose. I think there's good compelling evidence in the literature from a number of studies over a number of years that reducing milk production to 15 kilos or less at the time of dry off decreases the risk of intramammary infection during the dry period. So I think, and fortunately, I think there's, we've already been utilizing sensors for this purpose and will continue to do so. So I think that we're well down the road there. Next slide, please, Maria. So the other question then is about selecting cows for not receiving antibiotics at dry off in a selective dry cow therapy program. And that then devolves into a number of potential questions here as well, or sub-questions. Next reveal, please. So when do we want to know this? Well, perhaps a little bit different than our previous two speakers, given that dry off is a planned event, we can focus on this event and sort of narrow our concentration on a particular day or set of days where we're going to dry off a cow or a particular group of cows. So it allows us to, I think, better plan the data that we're going to use. Do we have sensors to provide the information? I would argue that yes, we do. And we have inline cell counters, we have conductivity, we have LDH, we have a number of metrics or sensors that we can use. The question then is, how good are these sensors for this purpose? Over the years, we've seen a lot of studies published, and again, I won't spend a lot of time here, but there are many protocols for selecting cows. Probably the most common ones involve some amount of somatic cell count data, usually from in herds that are on milk recording, with some combination of clinical mastitis cases perhaps as well. And that could be based on a single somatic cell count at the last test prior to dry off, or a series, and they may be weighted and so on. The challenge that we have, and if you look at the schematic at the bottom, is that we have that period between the last DHI test and then the period of dry off, that if we're thinking of a monthly milk recording testing interval, that could be days up to weeks, perhaps even a month. And there's a lot that can happen in that time period. And so having additional information from a sensor-based system during that interval, I think could be potentially quite useful. Again, there are a lot of tools that are available and that have been used to identify cows and to select cows. Again, cow side tests, the CMT, other cow side tests, certainly culture at the time of dry off or prior to dry off. I think there's some good and compelling studies that would suggest that these are valuable and useful. The challenge that we have is that I think we've struggled with getting these types of systems, particularly culture-based systems, implemented on most commercial farms, certainly in North, that's my experience in North America. So a lot of these tools have been evaluated for purpose. Certainly based on our review of the literature and what we've been able to find, there really aren't any studies that have evaluated the performance of the sensor systems for this particular purpose, or identifying cows with intramammary infections at dry off. So the considerations that we have, and I mentioned this previously, is this is a planned event. So we do have the ability to use more data to get it right, so over a longer period of time, and the timing isn't as crucial as it was, for instance, in the severe mastitis case that Ilka talked about earlier. We do want sensor systems and algorithms, again, could be multiple sensors that are reasonably accurate. Well, Henk already talked about higher sensitivity, potentially gives us more false positives, and so more antibiotic use, trade-offs with specificity, with more false negatives and untreated intramammary infections, potentially with major pathogens that could cause an issue down the road. We also understand that in different herds or even different regions, the underlying prevalence of intramammary infection is different. And so even with good performance characteristics, our predictive values or the sort of the interpretation of our tests will vary from herd to herd. So given that we have this situation where we can certainly have some variability amongst herds, what we have actually landed on as a team, next slide here, Maria, the big reveal, is that it's certainly not clear what is possible in the current systems, at least for this purpose. What we're suggesting is that we would like to see a system, a sensor or multiple sensors that give us probably a sensitivity at 95% or higher, and specificity also 95% or higher. That's probably a steep ask, but it's one that I think we would like to see as a goal. There certainly are some potential advantages to having more data available, but I guess I will throw in one cautionary note in the next slide. And that is that this is a tracing or a schematic of a daily somatic cell count for one particular cow over a 4-month period. What you see here is that there is day-to-day variability and test-to-test variability. Maria can just press enter one more time. And so regardless of what we pick as our threshold for identifying a cow as infected or not, even to the right-hand side of this particular schematic where this cow has an ongoing infection, there are particular days when her cell count drops below our detection threshold. And so there is an opportunity here, again, given that dry off is a planned event, that we need to think about perhaps this is the best application for things like smoothed averages and so on, where we don't necessarily rely on a single point, but we rely on multiple points and look at them in some kind of a smoothing function. Again, I think there's some opportunities to do some work here. The other thing is we recognize that these are indicators of inflammation and not necessarily infection. So we're still not far down the road without some culture-based system of even making the distinction between major and minor pathogens. So again, I think we've got some opportunities here and some work to do to try to bring together data from one or more sensors over perhaps not just a single day, but a series of days that I think can be used ultimately to arrive at a useful tool. So in conclusion, our experienced farmers do not tend to use sensor data to decrease production prior to dry off. I think the opportunity is there, but it doesn't routinely happen, although there is some good work going on now, particularly with some of the AMS systems, utilizing some of the capabilities there of developing and applying algorithms to do that. We certainly have sensors that could inform the treat or don't treat decision at dry off, but again, we haven't developed and validated the algorithms for this specific purpose, and I think there's an opportunity, and one might argue a need to do so. The other thing that I think we need to look at down the road with from the perspective of not only drying cows off, but dry cow management and our protocols is evaluating the outcomes of our treatments or no treatment decisions. And again, I think sensors could provide valuable information here as well, to alleviate some of the issues with the inter-DHI test interval and get some good outcome information much closer to the time of calving. Thank you very much.
Hello, everyone. I'm Henk, and I'm from Israel, and I'm a part of this team. And in this coming moment, we're gonna dive into a different, slightly different area, looking at the herd level. Most of the cases, we've been looking at the individual cow and identifying the individual cow, and then how she affects the herd. And now we're gonna step back a little bit and look at the whole situation from the sensor system on a herd level, and looking how we can manage the clinical and subclinical mastitis on a herd level. So in order to get a good overview of the herd level of mastitis situation, we need a day-to-day sensor system working, having the continuously monitoring the other health and have flow of information coming from our current sensor, and maybe a combination of those sensors. Next slide. And when we talk about it, we have to keep in mind that herd mastitis situation can change very fast, and taking in consideration that it can be multifactorial and it's contagious, as my colleague Gunnar said before, that we can have to remember, and it's drive very fast. So even if we identified one cow, we have to remember it easily can spread to the next of the herd. So once we have a herd being infected, then we have severe production loss, increased use of antibiotic that will be in certain countries all over Europe been trying to reduce, and of course reduce the animal welfare in that case. So what we want to do in those herd level point of view, we want is early detection of the changing on the herd level mastitis situation. So we just now move back and we don't look at the one cow changing, shifting, and then we look the whole herd, and then adequately respond and as adjust for the farm itself, quickly adjust the management to change. So as the colleague said before, if we saw something which is shifting, then we actually have to respond very fast. And then if we respond adequately and quickly, then we can prevent the extra mastitis cost and of course prevent the welfare coming with that. So when we look on a herd level, we want to take the KPI. If we take a moment and understand what is KPI, key performance indicators which support the process of a herd level monitoring. The KPI itself is used to detect any deviation from the farm expected or planned level of other health. So we create for each farm what we expect that the farm should get, or what the farmer and the veterinarian are trying to achieve. And every deviation, and we create the level of deviation, then we say, okay, then the KPI is not as we accept it, and we have to respond. When we look at the herd mastitis monitor today, then we know that the incidence, we monitor it by incidence of the clinical mastitis. And for that, in order to monitor the incidence of clinical mastitis, we have to have nice amount, established number of cases, and a nice time measure to get the right interval between one case to another, and in the herd level of incidence of clinical mastitis. So in order to get those right information, we need to collect it over time. We do use bulk milk somatic cell count, as we said before, and we use the average cow milk somatic cell count. The disadvantage of all those cases are just interpretation of this KPI is based upon statistic. It's not corrected to the farm itself. It's just a statistic that we have on a country level or in a farm level, or more than what we get. Okay, next. And what we get in this demand, what we need from the center system when we talk about the herd level, till now, we found the individual mastitis. We are still want to find it correctly and accurately. But once we get it, we want to get it on the herd level. And then we have the different aspect of the herd mastitis situation. And then the most critical is the herd overall situation. So we just more than just the herd mastitis, just the overall health. Because let me explain in one example what we are talking about. When I take, for example, the milk electricity conductivity, we have the farm average, then we have the average of the whole farm, and we put it on one scale and we see where we are going, and the distribution within the farm, and the percentage above the predicted threshold. We create for each farm his own threshold, and we know once we are there, or once we deviated from the average that we expect for the farm, then we know we are getting in a more difficult zone, and we can plan on a herd level, knowing something on the routinely base or something going on the farm, and adjust ourselves. And then we have, it's actually an indirect indicator to what the herd level situation is. Potentially, individual cow mastitis alert could be based upon multi-sensor system. And all our colleagues, we've been saying it, that we need multi-system together of sensors that will indicate us that we have a situation. On a herd level, we found less research and about that situation, and we need a lot more into that. Next, yeah. So again, we're going back again, as we said, all of us, we said about specificity and sensitivity. As Henk said before, when we talk about sensitivity, we measure the proportion of the positive that are currently identified, and again, specifically measured to the proportion of the negative that were currently identified. Yeah. So when we talk about the herd level, then we want to do it identified quickly as possible. Specifically, we want the herd level to be very high, and the herd level avoid any time consuming for false positive alert, because now we are not talking just the individual cow or the severely clinical one that we want to get to see her for sure. It just here, it might be false alert. We don't want to get that. On insensitivity, we want it high again. Crucial for early detection in order to prevent. In herd level situation, the shifting are sometimes take time, and it's getting slow if it's already spread. So we want to early detection as much as we can. The goal of preventive mastitis management is prevent the new infection, as Gunnar said before. The economic perspective, the expected expenses weighed against the reduction in production. And of course, the animal welfare, we have to, important to benefit the good other health we want to get in this management situation. The preventive plan that we know today, as Henk said before in the beginning, the so but on a herd level this time. And of course, that we mentioned, Ilka said it too, the prevention plan are generally on a dairy farm are not specific for farm itself. And what we know today, we have to adjust it to the specific farm. When we look at farms, it's a multifactorial nature of mastitis. They have large difference between farms and management aspect. And then we looked again at even the milking system is different. So not talking about country to country, but inside the country, we know we have such a huge difference, a deviation between every farm, then the general dairy is not necessarily will fit most of the farms. Next, yeah. When we go into the systems, we want to have the recording system, have a proper and consensus recording system that will give us a good evidence about the situation, the recurrent situation of the clinical mastitis and subclinical mastitis, which we have on this case. And we have it all the time. So we'll have the more information, as we said before, the more accurate we're gonna get. And the recording system should report about any warning about the suspected cow and showing any KPI deviation from the situation that we have. On a future direction, advanced decision process, the prudent mastitis treatment as required, that definition of health status of the cow is based on the sensor data, combined with other frame data, will be accurate and acceptable also for health authorities. So when I'm looking at it as a government, I have now points saying, from this point, we have a problem, and we look at it and we have to take more concern on a herd level health, or we can relax, but it have to be accurately adjusted to the farm, because a large scale farm again is not a small scale farm. And that's what we are lacking today. Thank you very much.
Conclusion. Very quickly because of matter of time, but at the moment, the sensor systems in place are performing satisfactory. Nothing more than that. The work can be done with it. It works, but things can be improved. Because udder health is, well, at the best the same, and often a bit worse than what it is with traditional milking systems. That leads us to thinking about novel situations, and we addressed 4 of them. So to really dedicate separate algorithms of sensor systems towards different situations to manage. And we discussed them about, well, what could we do with that? We also discussed how the performance should be optimized, and I saw some discussion in the chat about that as well. We believe as group that if we go that direction in the future, that it will lead to improved udder health and better use of sensor systems and a better support of the farm management, including prudent use of antibiotics and reduced losses due to mastitis. However, research and experience should show whether these types of algorithms are in fact possible. And we believe it is possible. We've been thinking about that, but well, we haven't proved that yet. Thank you for your attention. I guess there's some time left for questions.
So thank you to all of you. I am going to try to moderate this question. So if you have any question, please type it on the chat so I can direct it to the speakers. And I'm going to revise a little bit what you have been writing here. Yeah, the slides will be shared after the webinar and also the recording. So Ulf asks, since PPV, PNV are the characteristics that are useful for the farmers and not specificity and sensitivity, I think it is important to elaborate a bit more on suggested thresholds because the optimal value is very much depending on the prevalence of the condition that we try to identify. Henk, maybe this is a general question for you.
Yeah, it is. I already answered a little bit in the chat in the meantime, but definitely this predictive values are immensely important for the farmer. Yet because they're, and Ulf gave that point, they're so dependent on the prevalence in order to set the needed performance for census, which means that the developers and the industry work on, we need to make them a bit more closer to independent of a specific farm situation. But of course, I think we have to translate the sensitive specificity into a practical, what would it lead to given a certain prevalence. And for instance, Gunnar gave an example of that in his presentation where he showed the difference. For suppose we have to measure something at once per lactation and drying off, or something every milking every day, or maybe something that we do every week. And then, you know, prevalences change immediately if you do it that way, and performance will change that way as well. But it's very important to take that into account, definitely.
So David, are we able to get somatic cell count per quarter at AMS? What would be the proper cutoff for selective dry cow treatment per quarter?
Yeah, thank you, Maria. And yes, I responded to this through the chat, but so the question was, what's an appropriate threshold for quarter decisions? That's not an area that I'm have any expertise or experience in, for that matter. And I don't know that I've seen a lot of research that's looked at different cutoffs. I mean, presumably it could be a bit higher, again, because you don't have the dilution effect of the other quarters. I guess the other comment, though, that I made in that regard in the chat is that I personally am not a huge fan of quarter-based decisions, primarily because in the experience that I've had in clinical trials, there have been quarter clinical trials, even with very careful protocols, treating the incorrect quarter does happen from time to time. So I guess I think in most of our circumstances, and even in selective dry cow therapy, I think from my perspective, I'm much more comfortable making the decision at the cow level, recognizing that there could be some trade-offs. But I think a recent publication by Sam Rowe in his PhD out of University of Minnesota with Sandra Godden and some folks at Cornell as well, indicated that there really wasn't much of a difference in their quarter-based decisions or cow-based decisions in terms of antimicrobial use. So again, another reason that I'm a bigger fan of cow-based decisions.
Thank you, David. Now maybe a question is also very general, maybe Ilka can answer. This is a question from Ole Madsen. He says, going a bit into helicopter perspectives. So what are the ways here to use these systems to help meet the EU Green Deal goals of the Commission will reduce the sale of antimicrobials for farmed animals and in aquaculture by 50%? What do you think, Ilka?
Oh, that's a big question and an important target. And I think from the discussions here in the group, it is quite clear that we should support farmers much more to make more use out of the sensor data that is available. And by changing our view and moving towards the situation of the farmers, I think that is a great step ahead and will definitely help to reduce the antibiotics. Another point I was thinking about with the selective dry cow therapy, the Scandinavian countries, or at least in Denmark, you need to have a culture result, but it doesn't need to be on quarter level. So it could, as we always treat then the whole cow, sorry for the disturbance, and not on individual quarter level. So I would say selective dry cow therapy is important to reduce the antibiotic usage. And then the question is targeting the right cow. But if we find an infection in a cow, I think from the practical experiences that we have in Denmark, we would treat the whole cow, because otherwise she will spend her time with one treated quarter, 6 to 8 weeks somewhere. And there could be a risk, of course, of transferring. And you may not only detect the infected quarter. do you do this with the inflammatory marker? It's not often those cows that have the highest inflammation marker that are shedding bacteria and vice versa. So if there's one quota infected with Staph aureus, I wouldn't leave the 3 other ones without treatment, not at the dry period.
Yeah, and joining here maybe also with David, there's a comment from Lina. Quarter-based treatment for dry off should be on the research agenda for sure. I suppose this kind of research projects are going on in Scandinavian countries. Are there? In Ilka, do you know? It's just a comment that Lina was doing. For Dr. David Kelton as well from Lina. How do somatic dry cow therapy differ from quarter-based therapy at dry off? Same herd, same conditions. Do you know, David?
Yeah, thank you, Lena. And I guess I'm not sure exactly what you're getting at here, but let me take a stab at it. And I think perhaps it was in response to the comment that I made in terms of sort of some errors that occur in treating cows selectively at dry off at the quarter level. I guess, again, and based on my experience more from a research perspective, I think when we're treating clinical cases, there's the focus on the quarter, and I think quite often it's apparent which quarter needs to be treated. I think at dry off, a couple of things happen. Certainly in our system, we're usually drying off multiple cows, so it's keeping track of which cow is which, and then we've got quarters within cows that could get antibiotic or not get antibiotic. We're also quite often administering teat sealant, so there are a lot of things going on at the same time, and that seems to be, at least again in my limited experience, where some of the errors occur. So I think it is a different process. I think there are some different considerations there, but again, I would welcome others' comments and experiences in that regard.
Gunnar, Ilka, Henk, do you want to comment about it? Let them know.
I have a general comment on this predictive value discussion, because I find that we, as scientists, we are always focusing on what's correct, and we want to achieve perfect, or at least very close to perfect. But what we propose here is, of course, science should continue with this quest for the holy sensor system, but for the practical use, we should ask the question, is it helpful? Does the farmer know more after consulting the system than he or she did before? And if it's helpful, it can provide information that can improve health, welfare, and reduce antimicrobial treatment, or at least that is our argument. So we have to keep these two thoughts at one time. Of course, we want perfect sensor systems, but we do have to use the ones we have while we wait.
Thank you very much. Henk, do you want to comment something?
Well, I don't have too much to comment on this one. It's useful. You know, what's also a matter is whether things are useful, and often if there is a risk for making errors, then the negative effects of making an error may be worse than a positive effect of well, saving some money or saving some antibiotics or whatever. So it's the final thing as well is to kind of look, okay, what goes wrong, and that's what we also used in terms of our thinking about what our proper sensitivities and specificity to aim for. Well, perfect is of course what we aim for, but workable, good enough. And we do know that if we have such a high level of false positive results, as I showed in my data, then farmers will create their own algorithms not to have to follow all these cases. And that means that they may miss very important cases. So our aim as scientists is to come up with workable solutions and in the tools, and then also thinking about threshold. Well, if working the tool, if it improves versus not, and often if you talk about, if you had 4, 5, 6 false alerts in a row, you're going to throw it away and not use it anymore because it's lousy in your opinion, and that's the farmer's perspective. So what we try to do, and it's sometimes difficult as scientists, we try to put the farmer centered here. Okay, how can we support this farmer's decision making? And with the one-size-fits-all clinical mastitis detection algorithm, well, typically we can do better than that. That's something we work on, and this discussion, this webinar is also come on, and we saw people from the manufacturing industry, from milking machine companies. Wow, you know, given this, what are your ideas how we can go this direction, and how you can use your sensors to come up with it? And please, well, you know, collaborate with us. We can help you, whatever. But that's an interesting thing to go. So it's almost a starting point to go further than working on that. And yeah, that's an interesting, challenging aspect.
Thank you very much. And I think with that, I'm gonna put you a little video that we made, and I think it will resume quite well the recommendations. So you can find it as well on YouTube if you go to the DISARM project, as well as many other videos. So let me play it for you.
Uh-oh, that's going to be confronting.
Algorithms, sensors support farmers to monitor. In the dairy sector, treatment and control of mastitis is the most common reason for use of antimicrobials. Since the introduction of automatic milking robots on dairy farms, sensor systems that detect potential issues, and particularly clinical mastitis, play a major role in herd management. Sensor systems collect a vast amount of data. In combination with smart algorithms, sensors support farmers to monitor and improve udder health. Highly sensitive sensor systems and fast alerts allow early and efficient treatment of the affected cows. Sensor alerts should have reasonable sensitivity and a very high specificity to alert farmers to those cows that do not heal spontaneously and avoid the development of chronic mastitis. To support selective dry cow therapy, sensor systems should have a reasonably high sensitivity and specificity. This ensures that cows only receive antibiotics when they really need them. To monitor udder health status over time and raise alerts, sensor readings from all cows in the herd is combined to develop new key performance indicators. Sensitivity should be reasonably high and, due to the costs of further analysis of false positives, specificity should be very high. Sensor systems have a large potential to improve mastitis management and reduce antimicrobial usage. Collaboration among professionals is key for optimal mastitis diagnoses and treatments based on sensor inputs.
So with that, thank you to all of you, and I hope you have a nice day. If you have any more questions, you can of course send them to my email address, the one you use for registration, and I will share with the speakers. You will get also the recordings and the presentations that were shared with you. Have a good afternoon or have a good day. Bye.
Bye, everybody.